Hello guys, Hamzat Raghu Khan here with another video on channel HTK69. We are going to model Spur again, but this time we are going to be using millimeters as SI units in this system. First, let's look at the sketch curves whose names have been changed in this millimeter system. These are the curves that were previously in the inch system. The first two curves are the same. For example, the root dia and the base dia, they are the same for both the systems, but the pitch dia, outer dia and the circular tooth thickness, the names of these three have been changed to reference dia, tip dia and tooth thick respectively. Please note here there you need to check the spellings of all these curves, as if one mistake then you're gonna have an error and that can be really a pain in the ass. So for that to be removed, just check these spellings and be sure that they are right. And now let's look at the parameters and relations that we are going to use. These are the parameters. There are just four parameters in this exercise. The first one being the number of teeth, the second the module, the third the pressure angle, written here as the press angle, and the fourth one as the width. And now these are the relations that we are going to use. As you can see, they have the addendum to tandem, root dia, root fillet, etc. These are really scary things that you might have seen in any relations, but don't be worried, they are pretty much really easy to work around with. They are much easier than the previous system of inches that we have used. That was a lot of time taking and hard work. This will be a lot easier, as you will see in the upcoming time. Now let's take a look at the parametrics and relations that we are going to use. These parameters and relations are in comparison to both of the systems. And let's look at the comparison. Now here are the parameters. The left one shows the millimeter SI system, the right one shows the inch system. As you can see, the millimeter system has only four parameters that we are going to control. I have named these parameters in the previous slide. The right one shows the inch system. The first three are common. These are the width, pressure angle, and the number of teeth, but this system has three new parameters that are the pitch diameter, outer diameter, and the pitch diameter, outer diameter. These are the two extra parameters that this system uses. In the millimeter side, these two, the pitch diameter, outer diameter, are replaced by module. Module is simply 1 upon PD, the diameter pitch. You can find this relation in any of the machine design book on Spur. And now let's take a look at the relations of both of the system. Let's compare the two. For that, let's open this system. As you can see, each system have much less number of equations that we use, but the millimeter system have a lot of these equations, including a semi-topping and tooth thick. The last two, the root fillet is basically the round value and the semi-topping is the chamfer value. So don't be scared with these two, and rest are the same. I'm going to show you another picture where we are going to relate the curves and the relations with the curve that each circle represents. That will be at the end. Let me show you just here a quick look. As you can see, I have labeled the curves, the body of being the curve number 1, the second curve is number 2, that was the base, the third is um, the third was the pitch diameter in the previous system, the inch system, and the last circle being the outer diameter. They are now replaced by the new system, the millimeter system. The first two circles are the same, being the root dia and the base dia, and the third and fourth circles are now replaced with reference dia and tip dia. That is uh, most difference, the most differencing side of the story, and that is as long as it gets. There is no other difference in both of these. Now let's start with the model. It's getting longer and longer time. Open the file, click on new, uncheck the default template, give this any name you want. I will use k_1. click on part and click on OK. Use the millimeters Newton solid, click OK. Now click on tools, and like in any of our videos, we first are going to enter the parameters and relations, then we are going to work on the actual model itself. Let's enter the parameters first. Let me expand this tab. Enter number of teeth. Give this a value of integer and value of 18. Now enter width. Give this a value of 25 millimeters. Then press plus and enter press angle. Press is the short for pressure angle. Press underscore angle. Use the value 20 degrees. Now give the final parameter of module. Give the value of 7. Press OK. Now let's input the relations as I've shown you over here. These are the relations that we are going to use. Just copy and paste them over here. Click on verify. If the relations have been successfully verified, again if an error occurs over here, you have to check the font of this whole paragraph. For that you just type in manually all these relations, and hopefully the error will be resolved. Even in the case if the error is not resolved by then you need to check the parameters, the spelling of the parameters specifically. Press OK to click this prompt box. Go back to model, click on front and click on extrude. Extrude a circle of root diameter. Give this a value root dia. Root dia. Press OK. Give the extrude value of width. Press OK. As you can see, the parameters are now related to the relations. Click on front and click on sketch. Just as previously in the previous Spur video, sketch 3 circles with a little change in the names. The first circle being the base dia. Press enter. The second circle being the tip dia. Now the second circle is the reference dia. Press enter. The third circle being the tip dia. Tip dia was the outer dia in our previous system. Press enter. Click on OK. As you can see, the 3 circles are now created. Now we are going to create the involute curve for the tooth. For that, click on data, click on curve, and then click on curve form equation. For the reference, set the coordinate system and give the equation as the involute curve equation that is mentioned here. Just copy and paste this relation. Copy and paste. Verify the equation. Press OK. OK. Close the command prompt and click OK. Now the curve is created. Now we are going to mirror this curve over datum plane. For that we need a sketch and a point at the middle of that sketch. For that, click on front and click on sketch. Click on center and ends. Before doing that, we need to set some references. For that, select the middle, the reference circle and the involute curve circle. Press solve. Click close. Now click on center and ends arc. First select this point, then select a random length arc. And now change the dimensions from the reference line to these 2 points. Click the middle mouse button and give this a value of tooth thick. Tooth thick. Press enter. Click OK. Now click on point, give this an offset of 0.5. This means half the length of tooth thick. Press OK. As we are going to create a datum plane at this point, we have used the offset of 0.5. Now for the datum, click while holding control button, click on this central axis and the datum will be fully placed. Hold down control button, then press on this central axis. Hold down control button and press this central axis. Now the datum is placed, click on OK. And now from the model tree, click on curve 1, click on 3D mirror and click on the new datum plane that we created. Now that the curve is mirrored, press OK. As you can see, the second curve is now created. Now we just have one step ahead of us, and that is to sketch the teeth and extrude the teeth to till the width of the gear itself. For that, click on front, click on extrude and get in the sketch view. Now just disable all the views for the ease of our workability. Now we are going to use some references: the inner circle, the base circle, the tip circle, and the two arcs that we created. Click on solve and close the reference box. Then click on center and ends. No, don't click on center and ends. First we need to create the line. Click on the line from point here, place it over here, then mirror this line. We need to mirror this line over the central axis. You can do this in any way you want, any way you fit, but I see this as the easiest way. Click on center and ends and arc and construct an arc between this gap. First select this point, then select this point. The gap is filled. Now we need to project the two curves and the half circle over here. For that, click on 2D project, click on the two curves and click on the circle of the tip over here. Check the chain box and close the prompt. Now just clean the teeth a little bit. As you can see, the T sketch is now complete. Press OK. Give this a value of width. Press enter. Click on yes. Now please note here that I'm going to perform an extra step of providing the chamfer and round. You can skip the step and go on ahead to the 3D pattern over the axis. Put the pattern number as 18 and you will be done, but I will be going through the chamfer and round. For that, let's do and continue our video. Select the top two edges of the teeth, click on chamfer, give this a value of semi-topping without space. Semi-topping. Press enter, click OK. Now give this the bottom value. We are going to add rounds here. Click on round, give this a value of root fillet. Press OK. Now select the round chamfer and extrude 2 and put them in a local group. I'll show you how it's done. Select all these three files, click on local group. As you can see, a local group has been found. Rename this group as teeth. Press enter. As you can see, the tooth is now complete. Now we just need to pattern it. Before we pattern, click on axis so that axes are displayed. Click on this group and click on 3D mirror. Select axis and select the central axis. Now divide this angle over 360 and place the number of teeth to be 18. Press OK. As you can see, the gear is now complete with all the above parameters. Now let's take a look at the picture that I just used. As you can see, these are the circles that I have labeled and these are the values. This is just a reminder as a summary of the whole exercise. You are going to use the exact name that is placed in front of these numbers and you're going to replace the name with respect to the sketch of these circles. For example, if a value against tip die is placed as XYZ, the name XYZ, then you're going to type the name XYZ against this outer circle marked as number 4. This was just a little reminder. Thank you for watching. uh, Press the bell icon if you are new to the channel. Keep following the channel for more videos. Till then, goodbye.